We're going to look at using composition to show that two functions are inverses. And we're going to use examples that have cubics and cube root functions. So for example 1, f of x equals x minus 3 in parentheses cube, and g of x equals the cube root of x plus 3. We want to use composition to show that f of x and g of x are inverses. So remember, to do this, we must show that f of g of x equals g of f of x, and they both equal x. So first we'll find f of g of x. So I'm going to start by writing my f function, but I'm going to put parentheses where my x is, and then I'm going to substitute my g of x function in for x. So I have the cube root of x plus 3 minus 3 all cubed. And we'll simplify this. So the 3 and the negative 3 will cancel out and become a 0. And I'm left with the cube root of x quantity cubed. And since cube rooting and cubing are inverse operations, we're left with x. Okay, so we're halfway there. We do need to double check the other way, g of f of x. So let's find g of f of x. And I'll start by writing my g of x function. So the cube root of something, but not x, because we're going to substitute in f of x for x, plus 3. So let's substitute in my f of x, and that's x minus 3 in parentheses cube. So now simplifying, we're left with x minus 3 plus 3. And the negative 3 and the positive 3 cancel and form a 0, so we're left with x. So both f of g of x and g of f of x equal x. Therefore, f of x and g of x are inverses. Let's look at a slightly harder example, still again using cubic and cube root functions. So here in example 2, f of x equals 2 times x minus 1 quantity cubed, and g of x equals the cube root of x over 2 plus 1. So we'll start by finding f of g of x again. So writing my f function, 2 times something minus 1 quantity cubed, and I'll substitute in my g of x function in the parentheses. So I have 2 times the cube root of x over 2 plus 1 minus 1 all quantity cubed. That equals 2 times, now the 1 and the negative 1 in the parentheses, they combine together to form a 0. So I'm left with the cube root of x over 2, quantity cubed. And the cube root and the cubing are inverse operations, so we're left with 2 times x over 2. And when we multiply 2 times x over 2, we are left with x. So we're halfway there. Now we'll show g of f of x. So I'll start by writing my g of x function, the cube root of something over 2 plus 1. And I'll substitute in my f of x function, so the cube root of 2 times x minus 1 quantity cubed over 2 plus 1. And in the radical, my 2's cancel, and I'm left with the cube root of x minus 1 quantity cubed plus 1. And then the cube root and the cubing are inverse operations, so we're left with x minus 1 plus 1. And then the negative 1 and the positive 1 cancel and form a 0, so we're left with x. So again, f of g of x equals x, and g of f of x equals x. Therefore, f of x and g of x are inverses.